And this is another one of the questions from section 1's final exam, and it's also the last question from the last lecture. And also the TA will go through this in the review session in a lot more details. So here I'll just talk about how to solve this specific problem, not how to solve for mixed strategy Nash in general. So the first thing is we are assuming the row player is playing a pure strategy and the column player is mixing with probability Q and 1 minus Q. So the row player, in order for the column player to mix, if the row player plays U, then the column player is comparing 10 to 0, so the column player will play the pure strategy L for sure, so the column player will not mix. So the row player's pure strategy must be D. So the mixed strategy Nash should be D and L with probability Q and R with probability 1 minus Q. So because when the row player is picking D, then the column player is indifferent, so he or she is okay with any mixing probability. However, we need D to be the best response to this mixed strategy pair. So one simple sanity check is which one of this action is a pure strategy Nash. So the Q should at least contain that value. And here it seems 100% of picking R would work, because if say Q is exactly 0, so the column player plays R for sure, then the best response for the row player is also D. So D and R is a pure strategy Nash. So basically the range of Q should contain is 0. So basically Q should be 0 to some number here. And now we need to figure out what this number is. And this number should probably be when the row player is indifferent between U and D, but let's solve an inequality instead. So the condition to figure this out is D must be the best response. So D must be equal to the best response of the row player given the column player is mixing with this Q or this question mark. And that implies that the payoff from D should be larger than or equal to the payoff from U. And we can compute both. So the payoff from D is 0 times Q, so I get 0 with probability Q, and I get 9 with probability 1 minus Q here, because the row player's payoff is the first number, the column player's payoff is the second number. So we have 0 and 9, and comparing it with 5 times Q plus 0 times 1 minus Q. So we should be able to solve this quickly. And this is 9 is larger than or equal to 14Q. And Q should be less than or equal to 9 over 14. And also that confirms that Q must be larger than 0 for sure. And since this is a small or equal to sign, we have the range is between 0 and this, not this and 1. So we can put this here. So the answer to this question, the smallest number is 0 and the largest number is 9 divided by 14.